You know what I mean? And all of a sudden, they're in a rush to do this, although they called it a grand challenge. But we're going to find, we have a better challenge as part of this. Ours is an epic challenge. NASA, the president, there's a grand challenge. Okay, and so you saw something, and later we're going to talk about it, about how what do we see? What do we think the challenge is, or challenges are, and how we're going to do this. So I want to play you a little clip about how we're going to form together to do this. Bless you.
Now, my fair cousin, if we are marked to die, we are enough to do our country loss. And if to live, the fewer men, the greater share of honor. God's will, I pray thee, wish not one man more. Rather, proclaim it, Westmoreland, through my host, that he which hath no stomach to this fight, let him depart. His passport shall be made, and crowns for convoy put into his purse. We would not die in that man's company that fears his fellowship to die with us. This day is called the Feast of Crispian. He that outlives this day and comes safe home will stand at tiptoe when this day is named, and rouse him at the name of Crispian. He that shall see this day and live old age will yearly, on the vigil, feast his neighbors and say, tomorrow is St. Crispin's. Then will he strip his sleeve and show his scars and say, these wounds I had on Crispin's day. Old men forget, yet all shall be forgot, but he'll remember with advantages what feats he did that day. Then shall our names, familiar in their mouths as household words, Harry the King, Bedford and Exeter, Warwick and Talbot, Salisbury and Gloucester, be in their flowing cups freshly remembered. This story shall the good man teach his son, and Crispian shall ne'er go by from this day to the ending of the world, but we in it shall be remembered. We few, we happy few, we band of brothers, for he today that sheds his blood with me shall be my brother. Be he ne'er so vile, this day shall gentle his condition. And gentlemen in England, now abed, shall think themselves accursed they were not here, and hold their manhoods cheap, whiles any speaks that thought with us upon St. Crispin's Day!
Are we going to do this or what? All right, so think about it. All right? This is the epic challenge. We're going to bring this to the students, and we're going to solve this in the classroom. Okay.
All right.
Have our next speaker.
All right. My name is Nedya Abreu, and after that introduction, I don't know how to follow up. But I'll follow up with saying that this is my field area. I'm one of those lazy scientists. I wait for the asteroids to rain on us and then get to work on it. So I was told that I should tell you a little bit about my background. I'm an associate professor at Penn State Du Bois. I work on mineralogy of chondritic meteorites, and I'll tell you a little bit about the classification of meteorites in a second and how that fits into the entire picture of going to the asteroid belt. Just a little bit of background on the picture. That was the field season in which I went to Antarctica to go and collect meteorites. And that's pretty much that was our mode of transportation when we were on the ice. You have heard a little bit about asteroids already, so I won't get bogged down on the details too much. But basically, the bottom line is that they're floating potatoes in space. They're floating potatoes in space that are covered with dirt. which is a little bit of a nightmare scenario for astronomers to really learn about the chemical composition and the mineral composition of these materials. Because in addition to them being rather small, they're covered with space dirt, with regolith, that has been formed by collisions and also by their interaction with cosmic rays for literally billions of years. So what happens is that when you interact with those kinds of conditions for a very long time, you're going to get a relatively thick layer of material that is nearly invisible to telescopes. So if you are interested to what is underneath the layer of material, what you have to do is you have to study them through the meteorite collection. And the US has a fantastic meteorite collection that has mostly come from collecting meteorites in Antarctica. At this point, the latest numbers are around 20,000 meteorites, most of which came from the asteroid belt. And the asteroid belt is a fantastic place to learn about our solar system for several reasons. You probably heard in previous explanations about the asteroids that, in a sense, I wouldn't want to call them failed planets, but they have not had the kind of geological activity that a planet like the Earth has had. As a consequence, they preserve different stages of the evolution of planets in our solar system. Some of the most pristine ones preserve the earliest stages of solar system evolution, and those are the time when you started out with a cloud of material that collapsed and gave rise to the disk of the solar system. So if you look at the solar system, one of the interesting things that you have is you have a huge extension on the disk side, but it's relatively thin. And what that tells you is that you had rotation that made things collapse and into a fairly small disk, and what didn't collapse into that fairly small disk gets thrown out of the solar system. Pretty early on, what you had was the residues of stellar evolution. So you had the residues of other stars that got processed through that fairly violent stage. In that fairly violent stage, temperatures got pretty high, magnetic fields were quite wild, and as a consequence of that, you had melting of materials in space. So you have droplets that actually form in that stage and were collected by some of the most primitive meteorites. In addition to that, you have the building blocks of all living organisms. You have a pretty extensive catalog of chemical molecules that you're going to find in those asteroids, and as a consequence, you're going to find in the meteorites themselves. And when I get asked how broad and how complex of a sample of organic molecules you may find in meteorites, I just tell people, just pick your organic chemistry book, any page of it, and you're going to find it. There's literally thousands of organic compounds that have been identified in meteorites, and many of them are complex enough that you're starting to see some of the bridge between organic and biological. And in some cases, you might find adenine and guanine and cytosine have been identified in some meteorites. So getting close to the building blocks of DNA, you find sugars, you find alcohols, et cetera, et cetera. In addition to that, you have dust that came from other stars and give us our single source for materials outside of the solar system. So we can learn a lot about this stage of evolution from asteroids and from meteorites that are derived from those very primitive asteroids. In addition to that,